The first thing we must do, if we're going to set out to solve this logarithmic equation, is simplify the left side. When you see logs of the same base, there's usually going to be a way to combine them. And the main thing here is that there's a minus sign separating two logarithms of the same base. So the rule we're going to call on is that the difference of logarithms is the logarithm of the quotient. It's a really fancy way of saying that if there's a minus sign separating two logs, I can write them as the first thing before the minus sign divided by the second thing, all inside a singular log of the same base. So I've done nothing there but rewritten the left side. Now we're left with this slightly more palatable expression, and in order to solve it without getting too in-depth about the definition of logarithms, although it is helpful to know, if you have something like the log base a of c equal to b, there's another way of writing that. There's also an exponential form. This number a raised to this number b is equal to this number c. So another way of writing log base a of c equals b is a to the b power equals c. The reason for that is all tied up in the definition of what logarithms are, and it's worthwhile discussion, but I haven't got time for it right now. But I'll do the same thing here. Should be that this number raised to that number is this term. 5 to the second power is x squared minus 54 over x. 5 to the second power is, of course, 25, equals x squared minus 54 over x. And looks like I'm going to have a quadratic equation of some kind now. So by cross multiplication, we'll have 25x is equal to x squared minus 54. Getting everything over to one side, I have x squared minus 54 minus 25x, but putting in standard form is, of course, x squared minus 25x minus 54. This looks like something I will have to run the quadratic equation on. I don't see an easy way to factor it. So I'm going to do the process negative b plus minus the square root of b squared minus 4ac over 2a to get the two solutions to this. Substituting, that looks like it's going to be negative 25 plus or minus the square root of negative 25 squared, which is going to be 625. Minus 4 times a, which is 1, times c, which is negative 54, all over 2 times 1. So I'm going to do a quick round of simplification here. That will be equal to 25 plus and minus the square root of what? That simplifies down to, do it on my calculator here, 841, not the nicest root, over 2. That square root, if I decide to simplify it in decimal form, oh, to my surprise, it actually is an even root. This is 29. Beautiful. So it's 25 plus 29 over 2, also 25 minus 29 over 2. Finally simplifying to 54 over 2, negative 4 over 2, or 27 and negative 2. Silly me, of course. It would have been possible to factorize this, use the double bubble method. Need two numbers that add together, that multiply together to make 54, but add together to make negative 25, are going to be negative 27 and positive 2, and therefore the roots are positive 27 and negative 2. But the quadratic formula could have told you that. Sometimes you just don't see them, right? What are you going to do?